let us go through with the radiation pattern. Okay, so a polar diagram or a graph representing field strength or power densities at various angular position relative to the antenna. Okay, the heavy solid line representing points of equal power densities, 10 microwatts per meter square. The circular gradient indicates the distance of 2 kilometer steps, and this can be seen that the max radiation is in a direction of 90 degrees from the reference. So the primary beam is in a line of 90 degrees direction, okay, as you can see from the diagram, and it is called the major lobe. This can be more than one major lobe, okay, and a secondary beam, the minor lobe, the direction other than the major lobe, and normally the minor lobe represents an undesired reception or radiation, benda yang kita tak nak lah tu tadi. Okay, because of the major lobe propagates and receives the most energy, the lobe is called the front lobe, okay, and the front of the antenna. The lobe adjacent to the front lobes are called the side lobes, and the lobes opposite the front lobes are called back lobes. The radiation of the front lobe power to the back power is equal to the front to back ratio. Alright, next go to the antenna beam width. So the angular separation between the two half power is minus 3 dB points on the major lobe of an antenna's plane radiation pattern, as you can see here. The beam width of the antenna is angle formed between point A and point B, right? This angle. The point A and B are the half power points. The power densities at these points is 1/2 of what it is an actual distance from the antenna in the direction of maximum radiation. And the antenna gain is inversely proportional to the beam width. The higher the gain of the antenna, the narrower the beam width. Okay, we've talked about antenna bandwidth. What is antenna bandwidth? It is the frequency range over which antenna operation is satisfactory and normally taken as the difference between the half power frequencies, difference between the highest and lowest frequencies of the operation, and sometimes refers to the variation of antenna input impedance. So antenna input impedance is simply the ratios of the antenna's input voltage to the input current, represented by this equation, where Zin is the antenna input impedance in ohms and the antenna input voltage in voltage value, and antenna in current, okay, antenna input current I. Okay, antenna polarization. It is refers to the orientation of the electric field radiated with respect to one's axis x, y, or z from the antenna. Antenna can be linearly, horizontally, or vertically polarized, assuming the antenna elements lie in a horizontal or vertical plane, elliptically or circularly polarized. The antenna that radiates vertically polarized electromagnetic wave is defined as the vertically polarized, and that radiates a horizontally polarized electromagnetic wave defined as horizontally polarized. Electric fields are always parallel to the ground. The horizontally polarized is now, and the electric field are always perpendicular to the ground, where it is the vertically polarized. As you can see from this diagram, this is the vertically polarized punya wave, and then this is the horizontally polarized wave, right? It is just the position of the wave in which it travels. So in an antenna, there are many different types of antenna in our daily life. There are isotropic antenna, dipole, monopole, array, loop, and inside loop there are three different also: large loop, in between, and small loops, conical, and aperture. So in a monopole antenna, it is used primarily with frequencies below 2 MHz, and it requires a conducting path to the ground. So the actual length of the antenna is 1/4 wavelength, and by virtue of its conduction to the ground, it uses the ground as the other quarter wavelength, making the antenna is electrically a half wavelength. So this is because the considered to be a good conductor, that's why it is connected to the ground. In fact, there is a reflection from the earth that is equivalent to the radiation that would be generalized if the quarter wave section were used. So the reflection from the ground looks as if it's coming from the section beneath the ground, known as the image antenna. As you can see, this is how the monopole antenna looks like. How about half-wave dipole antenna? So any antenna having a physical length that is 1/2 wavelength of the amplified frequency is called a half-wave dipole antenna. So what that means is that the length of this dipole antenna is equal to the half-wave wavelength at the frequency of operation. It is more predominantly used with frequencies above 2 MHz if compared to the monopole, where monopole is below 2 MHz. Below 2 MHz, while the half-wave dipole antenna is above 2 MHz. This is what we usually see when we use in our old TV before this. This is how it looks like, the half dipole antenna. Alright, the other one we've talked about just now, which is the long periodic antenna, small loop, ferrite loop, folded dipole, and slotted antenna. It is the special purpose antenna. Long periodic antenna improve reasonably good gain over extremely wide range of frequency. Therefore, it is useful for multi-band transceiver operation and as a TV receiving unit to cover the entire VHF and UHF bands. These can be termed as the wide bandwidth or broadband antenna, consists of several dipoles of different length and spacing. The dipole length of the spacing are related by where it is called design ratio with a typical value of 0.7. This is how the antenna look like. It is quite similar to the half wave just now, but it has a very different use case.